Hi, I'm going to do work solutions to the Mechanics Assessment 3 that you just had a go at. I'm going to go in order of the paper, so if you know exactly what question you need to see, you can always just skip forward to find that one. But anyway, not wasting any time. Question 1 was asking you to find the magnitude of the vector minus 20i plus 21j. When we want to find the magnitude, well, we're going to be doing some Pythagoras, because this vector is looking something like minus 20i plus 21j. It's looking like this. The magnitude is going to find the length of this line. So 2021, find the length of right angle triangle, it's Pythagoras. So the magnitude is going to equal to minus 20 squared plus 21 squared, all rooted. And when we do that, we get 29. So 29 is our answer. And part B, it's a one marker, but I think it's a little bit harder than a one marker, because you do actually have to do a bit of work for this. So it's between the vector I, remember I is this vector and j is this vector. So when you draw yourselves an axis, this is your I and this is your j. You could write it like this. And when it says with the vector I, normally it'll say positive I, basically meaning you want to find the angle between this line, where I'm drawing my little notch up from, and where your vector falls. So on the coordinate grid, draw your vector. So minus 20i, that's 20 to the left, and 21j, that's 21 up. So this is our vector. So we actually want to find this angle. So straight off the bat, we know it's not going to be any of them. It's just a toss-up between these two. It's going to be somewhere around 135, isn't it, just by looking at it, because it's almost a 45-degree angle with them being almost the same. But we don't quite know how to do that, find that angle straight up, so I'm going to find that angle I've labelled in blue, because we can do that. I'm going to label that, I think that's alpha. I'm going to label it fish. So we got 20 and 21. So we've got a right angle triangle like this, and we want to find this angle here. Opposite, adjacent, it's going to be tan. So tan of alpha equals to opposite over adjacent. We want to do inverse tan of that. So when I do inverse tan of 21 over 20, I get 46.397, etc. It's not actually our answer though. To find our angle theta, which I'll do in red, we need to do 180 take away this. So when I do 180 take away that answer, I'm going to get 133.6 so on degrees. So it's not this one. Our answer is 90 to 135. They might have expected you to be able to see that off the bat. We know if it would have been 2020 or 2121, as in 21i, 21j, it would have been a 45-degree angle at this stage. With it being slightly higher than it was long, it would have been more towards the j-axis here than the i-axis down there. But there's nothing wrong with just doing the working out. Question 2. Find the acceleration. So it's only 1 mark, so it seems like it must be a pretty straightforward thing. When we've got a speed graph and we want to find acceleration, we need to find the gradient. I always remember this little flowchart. Distance, speed, acceleration. To get from distance to speed, we need to find the gradient of the line. To get from speed to acceleration, we need to find the gradient. And to get back, we find the area. And as you know now, that is going down here is differentiating, and going up here is integrating. So we've kind of taken that key stage 3-4 skill and adapted it into a Key Stage 5 skill with integration and differentiation. Anyway, so let's find the acceleration. We just want to find the gradient of this curve, of this line, sorry. So, the change in y over the change in x. The change in x is 10, the change in y between 3 and 8 is 5. So 5 over 10, a half, so the speed is a half, or the acceleration, sorry, is a half meters per second squared. And part B, I think I'm actually going to start it down in the corner, get myself a little bit more room. We've been told that the total distance is 120 meters. And as we know, we've been given a speed graph, and if we want to find the distance, we've got to go and find the area. So actually, we want to find the area of everything that's underneath where I've kind of blocked off with that black dotted line. I'm going to rub off my working from the last question just so it doesn't get messy. So we know 120 equals, and I'm going to split it up into shapes I know. I've got shape 1, I've got shape 2, and I've got shape 3. So let's find the area of shape 1. I'm going to do that up here. This is a trapezium. We've got a length of 8 here, a length of 3 there, so we're going to do 3 plus 8 over 2, and we're timesing it by the height, which is 10. When I do that, 3 plus 8 divided by 2 times by 10, that gets me, in red, 55. So I'm going to write down here 55, because I'm going to do 1 plus 2 plus 3, and that should equal to 120. So I found the area of 1 being that. I'm going to do this next one in blue. So, trapezium, again we've got a length here of 8, we've got a length here of 5, and we've got a width, or a height, if you tilt your head, of 5. So this is going to be 5 plus 8 over 2 times by 5. So if I do that in my calculator, I get 32. Where am I going to write this? I'll write it here. 32.5. So then when I write it down here, 32.5. And then the final section, well, this is, it says he goes for a further t seconds. So this distance here would actually be t. And that mark on the diagram would be 15 plus t. And we've got a height of 5. So the area of this is just 5 times by t, so 5t. And that equals to 120. So let's take away all of this to leave, we're just solving an equation, aren't we? So 120, take away 55, take away 32.5, gets us to 5t equals to 32.5, and then I just want to divide by 5. So I get t equals to 6.5 seconds. So that's that question done. Question 3 is down here. The first part I've split this into 2. I'm going to do the diagrams first, and then I'm going to have a go at part B, C and D. So in this question, use gravity as what we normally use it as. We've got a mass of a van, and we've got a mass of a crate. They're connected by a light inextensible rope. That means that the tension in all parts of this rope is the same. So we're going to have some tension here, and then we're going to have tension acting the other way at the pulley, and same there. This passes over a light smooth pulley. Well, that means, well, also when I mean inextensible rope, it means acceleration is the same for all of this in the system, for everything in the system. Light smooth pulley, that means we're going to have no frictional forces around the pulley, so we can just kind of ignore everything to do with that. So, first, maybe before you even look at the question, you want to read all this extra information, and you just want to get it on a better diagram than they've done. So draw yourself, that's my car, that's my box, this is my wall, this is my pulley and my rope, goes here. So I'm going to label on what I've got. I draw the masses inside. My units there would be kilograms. And then I'm going to draw the forces on. So we always have the weight, so the mass times by the gravity. And you always need a reaction force as well, what I label as R. We know it's not, we know this car isn't sinking or bouncing up, so you might think it's not worth putting these two on, but it is, because these two are the things that are stopping it from floating or sinking into the ground. So you need to label this, and that shows that it's stationary in the vertical plane. We're going to have that acting on here, and we're not going to be having a reaction force because it's not kind of resting on a ground. It's been held up by this rope. We're also going to have tension on this rope, and we're going to have tension on this rope here. We're also going to have it there and there. Label it as tension. The weight of the crate down here is not pulling, is not a force you need to label up on this van. It's the weight pulling down in here factors itself into the tension, and then you write it as just tension. You'll see later when we calculate tension it's not the same as what the weight is. So we've got a driving force of 5,000 newtons, which I've took from there. We've got a resistance force on the van of 780 newtons. And there's no resistance force acting on the crate. Okay, we've done our big diagram literally for this question. So forces on the crate, we just need to take this bit and just draw it out again. So you don't even need to put the mass in the middle, to be honest. You can just get away with doing 300 G and tension. That is it. And then when we get on to II, the van, you just need to take, there's a bit more on this one, just need to take what you've got pretty much directly affecting the van. Just draw that out again. So again, you don't even need to write the mass in the middle. We've got our tension. So there we go. That's our first 2 marks of this question. I have just taken what I've drawn on my big diagram and just split them up, and we'll see how this helps with our next question. I'm going to do a bit of flicking back and forth. Okay, I think I might be able to do a... No, I don't know how to do a copy and paste over. Let's not show off. So, we need to show that the acceleration is 0.8. When you get a show that question, you cannot afford to leave out any line of working. Because you've been given the answer, just by kind of getting your way to the right answer isn't enough to pick up, never mind all of the marks, but even some of the marks. You need to show every single piece of working you do to show that you understand how to get there. Because it's quite easy to bumble your way to an answer once you know the answer, without fully understanding it, and that's what they're looking out for. So you just need to show absolutely everything you are doing. That was a problem on a few people's. So something you can't do with this question. So I've re-recorded this video actually because I really wanted to pick up on this point. Something you can't do with this is take all of this system as one. Because once it goes past that pulley, and once it has the tension involved here, they're acting in different directions for one. So if we do, a lot of people did 5,000 and then they took away, was this 780, and then they took away 300 G, so they did this. This isn't correct. They did that for their force, because they did F equals ma. They did that for their resultant force, because they just did the forward, the down and the down. But, I mean, get someone to pull on your arm, someone pulls left and someone pulls down. you can tell the forces aren't balanced and they don't all act in the same direction, so you can't equate it like this. You've got to equate your left and right forces and your up and down forces separately. I mean, I don't know if this was just a lucky question, or if it seems to always work. I don't think it always would work. I'm pretty sure it was just a lucky question, but you managed to seem to get to the right answer for it, so that you might be a bit confused when you've got no marks or 1 mark or 2 marks for it. This is the reason. You can't equate. I mean, this is that direction, that is that direction, and that is that direction. You can't do that. They're not all acting in the same direction, so you can't equate them together. And then what people did is they added the 1,300 and the 300 and times that by the acceleration. That would be incorrect. What you need to do is take them separately. So I'm going to write van and crate. So over here I've got my crate and my van. I'm going to make some F equals ma equations from these. So first of all, we need to think, well, the car's moving forwards, it says. So acceleration is going this way. So when we equate these, we know the tension is going to be higher than 300g because it's moving in an upwards direction. So this force must be greater than the force pulling it down. So when I know I'm going to use my bigger force first, I'm going to do bigger force, subtract smaller force. And that's going to give me my resultant force, what I call in F here. We could put a little r there for resultant force. And then the mass is 300, and the acceleration is just a. We can't use 0.8 yet, we know it's there, but as soon as you use 0.8 in your working, you just get no marks instantly. Show that questions, that should just be your last line of working, and that is the only time it should ever appear. You should never use it within the question. So, let's do the same for the van. We're going to equate this to the right. We equated that one up because that was the direction it was moving. We're going to equate this to the right because that's the direction this van is moving when it sets off. So F equals ma. We've got 5,000, take away t, take away 780. And that is equal to the mass times by acceleration. Because it's an inextensible rope, this A and this A are the same. And that is how we're going to be able to solve this with some simultaneous equations. The acceleration is the same all the way through the system. So I'm going to just write them equations out in my answer here. So for the van, I've got 5,000 take away t, take away 780 equals 1,300a. For the crate, I've got this. So let's just tidy this up a little bit. So 5,000 take away 780 is 4,220, and I don't need to write that one out again. Okay, so we've got our two equations. This is where you get your first 2 marks for getting both of them equations. We need to eliminate t because we want to find acceleration. We've got 2 unknowns. We can eliminate one of them with simultaneous equations. So I want to add them because I've got a minus t. If I do minus t plus t, then I'm going to get rid of the t. I'll have 0 lots. So I'm going to line these up just to make it clear. You can, in your working, just write, you can label these, or you can do van plus crate. You can just make sure you label it out really clearly what you're doing with these equations. I've just written it out. I thought that was nice and clear. So when I add these, I'm going to get 4,220 plus minus 300g. So that leaves it like that. Minus t plus t is 0. And when I add these, I get this here. So, remember 300g is 300 times 9.8. So I've just done that in my calculator. I've done this sum, and I've got 1,280. Now I'm going to divide by 1,600. And I get A equals 0.8. Why they've specifically said 0.80 is because we've used gravity to two significant figures. We need our answer to be two significant figures as well. At the moment it's just one significant figure. And if I just pop a 0 there, that shows that it's two significant figures, and that really proves home that we haven't rounded it from like 0.78 or 0.83, rounded it down or up. By putting 0.80, we're just bringing home the point that it is 0.8, and we've not rounded it from anything further than where I've put that 0. Okay, and then on here I can squeeze the rest of them. Finding the tension, well, let's just take any of these. This one seems easier to me because the tension is positive. It's meant to be a T. And I'm just going to sub in my value of acceleration. This is a question you could have got, possibly, if you got the equation but weren't quite sure how to get the acceleration. So always look out for stuff like this. After I show that question, there's generally a question you can have a go at, even if you couldn't do the question before. So T equals to 300 times 0.8 plus 300g. So let me figure that out in my calculator. And we've got 3,180 newtons. That's my tension. You can go back and check that that is not the same as what the weight of the crate was, so people make a mistake there. We can see that mathematically it is different. And then the final question. These are horrible 1 markers in mechanics. Suggests how the assumption of constant resistant force could be refined to produce a better model. Well, what they're saying is no matter how fast this car goes, it's still going to be having the same 780 resistance force acting against it, possibly with wind because it's got a pretty chunky front end here. You'd probably know if you go running or get on a bike ride or just start walking when it's windy, you know the faster you go, the more wind gets chucked in your face and the more resistance you've got against you. So how we could refine this, what we could say is that the resistance increases as the speed increases. We could also say something about, I mean they neglected air resistance on the crate, so we could say add air resistance. If air resistance gets added to this crate, that's a further pull down. That means that's going to increase the tension, increasing the tension around here, and then increasing the resistance on the van as well. So there are two options. I always say with these mechanic questions, if you've got absolutely nothing, you cannot think of a single thing, I would probably say about 80% of the time the answer is something to do with air resistance. So that's your get out of jail free card if you're completely stumped in a test. And the final question. Okay, so I don't like this question because they use gravity as 10. That's a physics thing. Gravity is 9.8 in maths, and it should always be 9.8 in everything. But hey, let's go with it. We've got a lift. We've got a man, which I'm going to draw as a blob, and he is 80 kilograms. So that means he's going to have a force of 80 g acting down, and he's going to have a reaction force from the lift, keeping him up. He decelerates at a rate of 1.5. So the lift is rising as well. So the lift is going this way, but it's decelerating, so I'm going to label that as minus 1.5. So even though it's a minus number, that means we're just slowing down. Imagine braking in a car, you slow down, and then when you stop, if you keep going at that deceleration, then you'll start going backwards. Think about pressing the brake button in Mario Kart. Brake is the same as reverse. you've got to brake and get to stationary first before you can start reversing. So even though it's a negative number, because you're going up, you're not going to instantly just turn around. You've got to stop before you can start going back. So a negative number going upwards still makes sense. So we've just got an F equals ma straight from this. So resistant force equals mass times acceleration. We're resolving upwards because that's the direction our lift is moving. Our lift is moving upwards. So I want to do R subtract ATG equals the mass times by the acceleration. So ATG in this case is going to be 800, and AT times by minus 1.5 is going to be minus 120. I just want to add 800 to both sides. And that's going to get you 680 newtons. If you want to be super duper smart, we would say that it is equal to 700 newtons because our gravity is rounded to one significant figure this time, rather than 2 at 9.8. So we can only give our answer really to how accurate our numbers we've worked out with. So if you're being super specific, you don't generally get penalised for this, but if you want to be super specific, you want to give your answer to one significant figure, because that is as accurate as we can really rely on our answer being, because that is the value we've used for gravity, being one significant figure. Okay, I hope this video has helped, and that is all from me.